Where's my thing? Oh, here it is. Okay. So before we talked about maxes and mins, right? The Mount Everest and the Mariana Trench. Okay. And today we're going to talk about relative maxes and mins. So we're talking about just hills and valleys, not the extreme, not the highest and the lowest. But we're talking about sometimes we have bumps. Does that make sense? And we're talking about sometimes there are hills and the valleys. We're going to go find the hills and valleys. We're not just going to find the absolute max and the absolute min. Okay, and those are called relative maxes and mins, also called local maxes and mins. They're synonyms. Okay. All right. So those of you guys online, you can hear me. You're good. You can see the screen. Okay. So guys, remember you have a test tomorrow. Okay. And what else do I need to tell you? Okay, you have a test tomorrow. All this other stuff doesn't apply. Your test is on related rates, extremes, and MBT, and we'll talk about some of the things on your test in a few minutes. So when we talk about relative maxes and mins, see if this makes sense to you. Instead of talking about Mount Everest or the Mariana Trench, I'm talking about like when I went to Colorado and just went on a peak. Does that make sense? That was a hill, okay? Or if you go to Austin and go to Enchanted Rock, right? That's a relative max, but it's not the absolute max, okay? Let's go ahead and do some MBT problems right now. And this will actually be a good review for the test too. So if I give you a test question like this, if I said, hey, look at this function, tell me whether mean value theorem applies. If it applies, then tell me the C value where the mean value theorem guarantees, okay? If you looked at this problem, first remember you want to check, is the function continuous on the interval, the closed interval, and is it differentiable on the open interval? Those are the two things that are required to satisfy the mean value theorem, okay? All right, so well, it's actually to satisfy what we call the mean value hypothesis. So these two things need to be true first before you even go to the mean value theorem. All right, so guys, right here, is this function continuous on -1 to 1? No, so what would I do for this problem on your test? You'd say mean value theorem does not apply. And you'd go on to the next problem. Does that make sense? So if you spend a lot of time on problems where you don't have to do mean value theorem, you're going to get it wrong, plus you're going to waste time. Does that make sense? So always check. Look at this function. How do I know that it doesn't apply? Well, let's think about it. You need to know how to graph certain functions, okay? This function in particular looks like this, all right? It has a vertical asymptote here, x equals 0. Also has a horizontal asymptote. That doesn't affect the mean value theorem, but it does have a horizontal asymptote, all right? You're looking at points -1 to 1, this interval, okay? What's going on between -1 and 1 that doesn't allow mean value theorem to be applied? The function's not continuous, right? And the function's not differentiable. Everybody good with that? Actually, you only need one or the other, okay? And this one, it's both. You only do right one or the other. Yeah, Jonathan. Okay, sorry, I can't hear you. What? Yeah, you have a calculator on the whole test, except some of the problems will say, give me the exact value. And then you can't give me a rounded value. So you could use your calculator, maybe if your calculator does it, to find a fraction answer. But really, I want you to, and the question really just wants you not to use your calculator. But I'm okay with you using it. You just can't give me an approximate answer when they say exact answer. Okay. All right. Okay, so this is how you do this problem. MVT does not apply. All right, and then you just go on to the next question. Okay. What about a question like this? Same thing. Does MVT apply on this polynomial? Yes, guys, polynomials, it'll always apply because polynomials are continuous on all rows and they're always smooth curves too. So MVT does apply. So what you don't actually have to say if it applies, you just do it. But this function is continuous on the closed interval and it is differentiable on the open interval. And that's why we can use MVT, okay? And again, you don't have to say this before you apply it, unless they tell you to, to show it. All right, this just says, hey, figure out if you can apply it, and if you can, then do it. All right, now I'm going to go ahead and do MVT, but question, what is MVT anyway? What do I do when I do MVT? Am I gonna take the derivative and set it equal to 0? No, that's how you find extremes. Everybody good with that? Don't get this confused with MVT. What is the MVT formula? Very good. That's the right side of the formula. then this is the left side of the formula. You guys good with that? MVT says there is at least 1 point. There might be more points, but there's at least 1 point, okay, when the derivative is equal to the slope of the secant line, or when the slope of the tangent line is equal to the slope of the secant line. Now make sure you guys realize that this is not always true. Like some students will be like, oh, remember this MVT formula? That's the form. Like it's not like a physics formula where you say like, you know, V equals IR, F equals MA. Like that's always true. Does that make sense? This is not always true. It's only true for 1 point, or maybe 2 points, or maybe 3 points. Does that make sense? But it's not true for all the points. And so this is just the way you find those points where it is true. Okay, so let's go ahead and do it. On the left side, you're going to take the derivative, right? On the right side, this is your A and this is your B. So this is f of 1 minus f of negative 3 over 1 minus negative 3. Okay? What do I do with this f of 1 and f of negative 3? Okay, make sure you understand. I always take it to the side. The reason is because when I don't take it to the side, these negative signs, I usually end up doing it wrong. Like I forget to distribute the negative. So I always just take it to the side, find these answers separately, and then I plug it back in. So what's f of 1? Well, that just means here's my f. Everywhere there's an x, I'm going to put in 1. So that's 5 times 1 minus 2 times 1 minus 3, which gives me 7, which gives me 4. 5 minus 5. No. Oh, it's 0. Thank you. Okay. What's f of negative 3? That's going to be 5 times 9 minus 2 times negative 3 minus 3, which gives me 45 plus 6 minus 3, which gives me 48. Hopefully I did better with that one. Okay, so we're going to just plug in. So this is going to be, see if this makes sense. I'm going to work downwards. Okay, so this is going to be 0 minus 48 over 4. Okay, 1 minus negative 3, be very careful with this. 1 minus negative 3 is 4. Okay, this gives me negative 12. And number 1 common answer, if students even get the equation right, assuming you even got the equation right, number 1 common answer is to box this in and say that is the right answer. This is number 1 wrong answer. What did I do wrong? I put in f of b minus f of a equals b minus a. Wasn't that the formula? I never found c. I never found x, okay? The whole reason to do MVT is not to solve for the slope of the secant line, okay? I wasn't trying to solve for the slope of the secant line. I'm trying to figure out where the slope of the tangent line is equal to the slope of the secant line. So the right way to do this is actually to set this up into an equation, solve for x, and I get an answer for x. Okay, now this x, though, you need to test it. Is it in your interval? If it's not in your interval, then you just say there's no answer. There's no point on that interval where the slope of the tangent line is equal to the slope of the secant line. Okay, but you need to make sure it's in the interval. So let's go back. Is negative 1 inside this interval? Yes, so that is your answer. X equals negative 1. Okay, if your answer is on the endpoints, then that's also not an answer. MVT doesn't guarantee that, although it could possibly be true that the slope of the tangent line is equal to the slope of the secant line there, but MVT doesn't guarantee it. Okay, all right, so that's how you do MVT. I have kind of another question regarding MVT on your test. And can you take a look at this question and think about what you would write on your test? So this is saying, hey, look at this graph on the right. MVT doesn't apply. Why not? I thought that the slope of the secant line was always equal to the derivative. Why doesn't MVT apply? Yeah, the function is not differentiable. You could also say the function is not, what else? Continuous, either one. So guys, if you see this on your test, which you will, there's a free response question, okay? And what I want you to write is this: the function is not continuous on the closed interval, which is 0, 6. Or you can write the function is not differentiable, if it's true, okay? In this case, both are true, on 0, 6. So you can write either or. Yes. Yes, it's not differentiable at 0, but remember, with MVT, you don't care if it's not differentiable at the endpoints or not. You don't even have to consider it. But you're right, it's not differentiable. It's not differentiable at 0. If you look at the picture, it's not. Yeah, that's what it means. It's open. So it's not differentiable. This is saying it's not on the interval from 0 to 6. I've got something that's not differentiable. Does that make sense? And the difference in, okay, so this says the function. So in order for MVT to apply, you must have two things. One is continuous on the closed interval. And so you can see that means count this, and you've got to be continuous on the closed interval. And you're actually not. Does that make sense? You're not continuous on the closed interval. Actually, that's a good point. The definition of continuity can be specified as continuous from the left or continuous from the right also. I'm not going to worry too much about that. I think the main thing we're looking at is the whole thing continuous? And the thing is, it's not continuous on the whole thing, okay? And then when we're looking at differentiability, we're looking at, is it continuous? And you don't have to consider, like, don't worry about these endpoints. Is it continuous here, not counting the endpoints, okay? So technically, this one, it's not continuous here and not continuous here. So really, it's not continuous on this, but it's actually not continuous on this either. It's not continuous on either one, but it doesn't matter. If it's not continuous on this, it's not continuous on this, okay? So, yeah. Believe me, I'm not going to be too picky on that. You just need an understanding of that, okay? All right, so either or is what you'll write, this statement, one of these statements. Okay, and that does require you to know when things are differentiable and when things are continuous. That differentiability, remember, when are you not differentiable? I am like you and you're like me, no differentiability. So you're going to check out anytime you have a sharp turn, vertical, tangent, any discontinuity. And what are my discontinuities? Joy, hole. Anytime you have any of those 6, you're not going to be differentiable. Okay, so check that out. All right, you have a problem like this on your test. And I wanted to point out, because I didn't talk about, we didn't do a problem like this by ourselves. But when you have a rectangle, your negative signs actually matter. They actually matter. And so let me show you a problem where it would matter. If this is a rectangle, I've got a length and a width. I'm told that my length is increasing at a rate of 5 centimeters per second. Okay, so guys, what is that in calculus talk? The length is increasing. dl dt equals 5 centimeters per second. I'm also told the width is decreasing at 5 centimeters per second. So what is that in calculus talk? dw dt. But do you guys see the width is decreasing? So I'm going to set that negative, okay? On previous problems that we did, you actually got the right answer. I mean, you might have gotten a negative answer rather than the positive answer, or vice versa, but you got the right magnitude, whether you did positive or negative. But this is a problem where it actually matters. So let me show you why. It says when the length is 24 and the width is 7, is the length always 24 and is the width always 7? No, this is a moment in time. So I'm going to do a moment in time picture. Okay, in that moment in time picture, I have a length of 24 and a width of 7. It says find the rates of change of the area, the rate of change of the area. So what I'm looking for is dA dt when L is 24 and when W is 7. Okay. All right, so first question then, I've got a picture, I've got a rectangle, I've got an L, I've got a W, I've got an A. What is my formula going to be? Okay, area, what's the area of a rectangle? Okay, L times W. What are you going to do next after you get the formula? Take the derivative. Okay, number 1 wrong answer. You ready? dA dt equals dL dt times dW dt. Why is that wrong? It's the product rule. Okay, you cannot just say, in limit land, you can do this. You can kind of distribute that limit, but in derivative land, you have to use the product rule. Okay, so this is wrong. You have to say dA dt is equal to the derivative of the first times the second plus the derivative of the second times the first, okay? And I don't know why, but the number 2 wrong thing that students do is instead of doing the product rule, I don't know why, they take this and they line it up. So instead of dl dt times w, they'll be like dl dt times L plus dw dt times w. That works in the Pythagorean theorem problems, you know, those that we have, but this is not how you do product rule, okay? You actually have to do the real product rule, okay? You don't just line up variables the way you want. It's not like a pretty picture kind of thing, okay? It's actually a rule, a product rule, all right? So now I'm just going to substitute in. So I have dA dt equals what? Well, do I know dL dt? I think it's 5. Do I know my w at a moment in time? 7. Do I know dw dt? -5. And do I know my length at a moment in time? 24. So if you calculate this, dA dt equals, I don't know if you have a calculator. What's 35? I don't know what this is. Minus 5 times 24. Did anybody get it? Negative something. -85. Okay. And let me get my units in. Just in case they ask you for units. What's my units for area? Go find a length and square it. What's my units for time? Go find a time. Okay, and that's my answer. Okay, so do you notice that had I not had a negative here, do you see you would have gotten the wrong answer? Most of the time it doesn't matter, okay? But there are situations when it does, and then this would be one of them, okay? So be careful on your length and width problems for rectangles. Okay, let's talk about homework questions. What questions did you guys have on homework last night? What questions did you have? Can you guys call it out? Okay, can you tell me the problem? Minus what squared?
11x.
Okay,
Minus 6x.
minus 6x.
On the interval, -4.
It's a closed interval? Okay. Are we doing MVT on this problem or is it an extrema problem? It's an extrema problem. Okay, so make sure you guys have both extrema problems and MVT problems. Okay, Matthew, your question? It's what? Oh, it's plus 11, thank you. Okay. Guys, make sure you have both problems and you do different things, okay? Depending on what the problem asks. All right, this is an extrema problem, so what you want to do is get everything into a candidates test. Okay, that's your end goal. Find the largest and the smallest. To get everything into a candidates test, you need to put 2 things into the candidates test. The first thing is the endpoints, okay? The second thing is the critical points. Now, do you remember how to find critical points? Okay, you take the derivative and set it equal to 0 or d/e. Take f prime. So the derivative of this would be 8x cubed plus 22x minus 6, set it equal to 0. You also set this derivative equal to d/e, okay? And for a polynomial, guys, when you set polynomials equal to d/e, which is 1 over 0, you always get something funky like 0 equals 1, and there are no critical points generated from setting a polynomial equal to d/e, okay? But on this side, you actually get an answer. You can actually factor out, I think, 2. I always like to factor out first because I'm not really that good at FOIL or factoring. And so if you can factor out like things before you do the factoring of quadratics, it makes things a lot easier. Okay, so then, see if I did that right. I'm going to factor this. And guys, you need to get good at factoring if you're not already. You don't want to spend all your time factoring, okay? And so what I get, hopefully I did this right after I lectured you guys about being good with factoring. What I get is something times something times something equals 0. And in math, if something times something times something equals 0, what does it mean about one of these somethings? One of them must be 0, okay? And so that means 2 equals 0, which that's silly. Or 4x minus 1 equals 0, that means x is 1/4. Or x plus 3 is equal to 0, which will give me x is equal to -3, all right? So guys, these are what I call my critical points, okay? And what do I do with my critical points? I stick them into the number line. That was my whole reason for finding them in the first place, okay? And you want to stick them into the number line in order. So the 1/4 is over here, the -3 is here. Okay, it's not super important actually that they're in order, but the more super important thing is that the numbers that are critical points are actually between the endpoints, okay? If they're not between the endpoints, you disregard them. Because the question was, find all the absolute extremes inside your interval. And if it's outside your interval, who cares, right? You're not looking for things outside your interval. All right, so let's plug in. This f of x would be, and guys, you guys have a calculator, right? So you can do the second table auto ask, you know what I'm saying? Change your auto to ask, and you can actually just put this right into your table, and it would generate a table that looks exactly like this, okay? But anyway, I'm gonna do it by hand because I don't have a calculator here. So this will be 8 times negative 64 over 3 plus 11 times 16, which was, oh, I'll just put 11 times 16, minus 6 times 4, which is positive 24, okay? Right here with negative 3, it'll be 8 times negative, so it'd be 9. 8 times negative 9 plus 11 times 9 minus 6 times negative 3. So that's going to be plus 18. Right here, you're going to put in 1/4. 1/4 raised to the third power plus 11 times 1 over 16 minus 6 times 1/4. And then you plug in 1, which would be 8/3 plus 11 minus 6. Can I leave you guys here? Okay, all you need to do is find the largest number, and that's your max. Find the smallest number, and that's your min. Okay? All right, what other questions do you guys have? That's extreme, guys. No MBT problems? You guys are good on MBT? Okay, then let's move on then. Okay, today we're going to do relative maxes and mins, and you need to fill out this chart, okay, in your notes. The first question says, when f prime is positive, then what do you know? You actually know that f is increasing, okay? And what does that mean? That means if you have a positive slope, and it doesn't matter, you know, how your positive slope is. Well, I'll just do a positive slope. If I have a positive slope, then do you see that my function is increasing, right? And if I have a negative slope, then guess what my function's doing? It's decreasing. And if I get f prime is equal to 0, then what's happening there is that f has a critical point. Okay, so those are the 3 things you need to know, all right? And it should make sense. The one thing I do want to talk to you guys about is if you have a positive derivative, so I'm going to make a curve here, see if this makes sense. This is my curve, here's my x, and here's my y, okay? If I go on any point on this curve, do you agree that my derivative would be positive? I mean, you can put your hand there. I mean, my derivative is always going to be positive on this curve. Do you agree that f is increasing all the time on this curve? Now, what I get kind of strange from students, and this might be funny right now, but it's not funny when you don't understand it. I'll have a curve like this, and students would tell me that this is decreasing. And I'll be like, why do you think that curve is decreasing? And they'll be like, look, it's going down. Guys, when you talk about increasing and decreasing, do you understand you're talking from the left side and you're going right? Does that make sense? It's never right to left, okay? So this function is actually not decreasing. This function is increasing. Does that make sense? You're always going left or right to talk about increasing and decreasing, okay? And then, you know, a function like this would be decreasing. You always go left to right, okay? The other thing I want to talk about is that increasing and decreasing, or increasing is not the same as positive. Increases is not the same as positive. For example, this graph right here, I could draw it. This graph right here, isn't this graph increasing, but it's a negative graph? Is everybody good with that? So increasing and positive, they go together sometimes, but they're not the same things, okay? All right, let's look at the first derivatives test. This says that if ever I change from positive to negative, okay, then what I'll have is a relative maximum. You can also say local maximum, it's the same thing. So relative or local, okay, same thing. And if the derivative changes from negative to positive, then what you have is a relative minimum, okay? Now, not to be confused with a minimum. If you just say a minimum, that means absolute max and absolute min. That's totally different from relative max and relative min, okay? If you just say the word minimum, that means Mariana's Trench. But if I say relative minimum, then you're talking about maybe Death Valley or the bottom of a puddle okay, or the bottom of some valley, okay? So that's relative minimum, which could also be called local. Okay, let's see if this makes sense. If my derivative changes from positive to negative, so let me give you an example. My derivative is positive, then my derivative goes negative. Everybody good with that? This is a positive slope, right? This is a negative slope. Do you agree that right at the top there, I'm going to have either a smooth curve or a sharp turn, either one, right? Whether it's a smooth curve or a sharp turn, don't you agree that that would be a relative max? Okay, you're right. If it were a sharp turn, it wouldn't have a slope. Okay, but I'm not asking if it has a derivative or not. I'm just saying, does it have a relative max? Yes, even if you have a sharp turn, you have a relative max. And same thing here. If f prime changes from negative to positive, so if I have a negative slope, then I change to a positive slope, do you agree right there? That would be a relative min, right? And that relative min, it could be a sharp turn, okay? Or it could be a smooth turn. It doesn't matter, but it's still a minimum. Everybody get a relative min, okay? All right, so what we're going to do is we're going to look at a problem, and we're going to find where the intervals are increasing or decreasing on f, and also where there's a relative min and a relative max on f, okay? Without actually graphing the picture, okay? So let's see if we can do this. All right, you've got a function, okay, and of course this one's pretty easy. We actually know what this one looks like, so that's kind of nice that we know what it looks like, okay? But what we do first, when you're trying to find relative mins and maxes, is that you take the derivative and find the critical points. So let me just say, it's just like the extremer problems, okay? You find the critical points. So I'm going to take the derivative, I'm going to set this equal to 0, and I'm going to set the derivative equal to dne, okay? On the left side, what I'll get is 2x is equal to negative 8, or x is equal to negative 4. On the right side, since this is a polynomial, what will happen is this is over 1, I cross multiply, and I'll get no critical points generated from setting the derivative equal to dne. But I do get one critical point generated from setting the derivative equal to 0. Now, if I were to find absolute maxes and mins, okay, what I would do is I would set up a candidates test. Okay, now things are about to get confusing because now I'm about to give you lots of different ways to do things. So hopefully you've been understanding your homework and you understand that extremas are not the same things as MVTs, and they're not going to be the same things as relative max and mins. If I go here and I put in my endpoints, well, look at this. I don't even have endpoints. Do you guys see that? But let's say I had endpoints and I put in my critical points. What the candidates test does is it tells me all of these, there are probably relative maxes and mins in them, but you can't tell which ones are relative max and min, okay? All this tells me is the largest and the smallest. That's all I can get from a candidates test, the largest and the smallest. In order to do a relative max and min, what you have to do is set up a number line. And we call this an F prime number line. And you're supposed to make it horizontal, not like that. But anyway, you set up a number line and you stick in all your critical points into this number line. Okay, in here I've only found negative 4 as a critical point. And remember, your critical points are where your f prime is equal to 0 or dne. It's all your sharp turns and all your smooth turns. Okay, so what I'm going to do is I'm going to set up all my sharp turns and smooth turns. And do you see, if I can find all my sharp turns and smooth turns, I can see where it's increasing and decreasing. Because it's increasing and decreasing before and after my sharp turns and smooth turns. Okay, so then what I do is I find a number in here and I make up my own number. But it's any number, it's called a test. So I test a number, any number that's less than negative 4. Okay, so what's a number less than negative 4? I'm not going to go crazy right now. I'm just going to pick negative 5. But you can pick any number. You could pick negative 10, negative 100. Okay, over here I do a test question too, and I pick a number greater than negative 4. So this is a regular number line. So usually I pick 0 if I can, or 1 if I can. Okay, so I'm going to pick 0. Okay. Then you test this. You say, where is f prime positive or negative? Well, where is my f prime? Do you see here is f prime? You go look for your f prime. And you figure out if your f prime is negative or positive. So at negative 5, if I plug in negative 5, do you see I'll get negative 10 plus 8, which gives me a negative number. It doesn't matter what that number is. But what I know is if I plug in any number less than negative 4, I'll get a negative number. You can test it. Try negative 10. Try negative 20, okay, you will get a negative number. Then test your right side. This is a 0. So if I test 0 in here, do you see what I'll get is 0 plus 8, right? And that is a positive number. So what I do is I just put a bunch of positive there so I don't get confused. Okay? And so this is what this picture looks like. In this graph, however this graph looks, f prime changes from negative to positive. Here at negative 4, f prime is negative less than negative 4. Well, guys, remember what we learned today. We learned, let me move this over to the right. Okay, we learned, and this is something super important that you need to be able to write on your own, that when f prime is positive, f is increasing. And when f prime is negative, f is decreasing, right? You wrote that in your table, but this is kind of like a shortcut way to write it. If you ever change from f prime positive and negative, what's happening there is called a relative max. And if you ever change from f prime negative to positive, what's happening there is called a relative min. So I always write this on my paper. Like before I take my test, I would write this down because this tells me everything that was in that table, but in a very short, compact way, okay? And so what this says is, look, whenever f prime is negative, then f is decreasing. So if I wanted to know what f was doing between negative infinity and negative 4, f is decreasing. And look, f prime is positive here. So whenever f prime is positive, f is increasing. So I'm going to draw an f picture there. I'm going to label this f. So this number line represents my f prime, the positive and negatives. But this picture that I just drew represents my f, okay? And so f looks like this. F is going to be decreasing, and then it's going to be increasing after negative 4. Guys, what do you know about a parabola? Is that what's happening? Yeah, this is a picture of my parabola, okay? And so the first question is to tell me, or to tell, I guess, tell the problem, I guess, when is f increasing? So you look at your number line, between your number line and this little compact formula, it tells you everything. So when is f increasing? I can see f is increasing between negative 4 and infinity. You guys see that? If you did interval notation. Another way to write that, which isn't wrong, is you could say x is greater than negative 4. Oh, is that right? Yes. You could say either or. It doesn't matter which notation you give me, okay? You need to justify this. Why is f increasing? Okay, so you go look at your compact formulation here, and you say, f is increasing because f prime is positive. So your justification will be because f prime is positive. And AP is super picky on justification. Actually, I wouldn't even just say AP. Like calculus is super picky. Whenever you say something, you got to say why. And the reason is because f prime is positive. Okay. When is f decreasing? Okay, well, f is decreasing. I can look at my picture and say it's decreasing between negative infinity and negative 4, right? Another way to say that is when x is less than negative 4. Why? Justify that. Okay, go look at my compact formula here. Whenever I see f is decreasing, I see that f prime is negative. So the reason will be because f prime is negative, okay? And just for notation's sake, this is how I write it. It's actually kind of a lazy way to write it. You would probably see, if you saw answer solution, you'd probably see that. Does that make sense? If you saw a key, instead of f prime negative, you'd probably see f prime less than 0. Okay, so I'm just letting you know, you could do it either or. Another way you could write it is f prime is positive. You could write it out like that. You could write f prime as negative. Okay, I kind of do the lazy man's way, but you guys can do it any way you want. Okay, all right. The next question is not just where f is increasing or decreasing, but when do you have a relative max or a relative min? So let's talk about relative max first. Go look at my picture. Do I ever have a hill? No, so I would say D and E, no relative max. You could even say no relative max, that's fine. You don't have to justify this, but if we were to justify it, we'd say because f prime never changes from positive. F prime never changes from positive to negative, if you were to justify it, okay? But let's justify my relative min. Where is there a relative min? Do you see on my picture, there's a relative min. Make sure you understand, this is when x is equal to negative 4, not y. Because this value down here was my critical point. That's my x point. So when x is equal to negative 4, that's my relative min, okay? What's the justification for relative min? Go look up your compact formula here. A relative min happens when f prime changes from negative to positive, okay? So your justification will be, okay, because because f prime changes from negative to positive, okay? You cannot just say f prime changes signs, because f prime changes signs could also be a relative max, okay? So you must say f prime changes from negative to positive. Okay, if this is the x value where the relative min occurs, if I wanted to know where the point of the relative max is, because this is a parabola, right? If I actually wanted to know that point, okay, what this is saying is that your x value is -4. How would I find my y value? Yeah, you plug it into f. Now, would I plug into f though, or f prime? Because there's two functions up there I'm looking at. F, okay, make sure you understand. F is a code word for y, but f prime is not, okay? So if I were to plug -4 into f, let's see what I get. So f at -4 would be 16 minus 32 plus 10, which is -16 plus 10, which is -6. You guys good with that? So if I were to plot this parabola, what I would know is that this point is -4, -6, okay? Pretty cool. And so, you know, I guess x would be like, oh no, x wouldn't be like that, sorry. Putting the graph all in the wrong place. It would be something like that. Does that make sense? There would be my x and there would be my y. And this parabola has a vertex at -4, -6. Kind of cool, okay, knowing all that stuff with calculus. You ready to do another problem? Okay, so you guys do this one. Go ahead and find the critical points first. You're going to do the same thing. You start out just like you're finding the extremes. But the candidate's test is not going to help you find relative max and min. I'm going to factor up my 3x. I think that's going to help me the most to find my critical points. Did you guys find your critical points? I got 0 and 4. Everybody good with that? Okay. Now, what students do is they confuse this with the extremist test, okay? We're not going to stick this into a candidate's test. First of all, two things. One is we don't even have any endpoints. You guys good with that? Now, how are you going to stick this into a candidate's test without endpoints? Because EVT says that if you're closed on a continuous interval, if you're continuous, sorry, on a closed interval, they're not even continuous on a closed interval, okay? You don't even have an interval. Okay, so instead of doing a candidate's test, what you're going to do is you're going to do a number line. You're going to call this an F prime number line. Make sure you label it. I can't say how important it is to label your F prime, because eventually we're going to start getting our F's confused with our F prime, okay? And the more you can prevent that now, the better, okay? This one actually has 2 critical points, so you can put in both critical points. Do you remember what you do next? You want to get plus, 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 minus, minus, minus. Does that make sense? So the way you do that is you put in test points. So I need a test point for every interval that I have. I have 3 intervals now because I have 2 critical points. Okay, what's a good test point less than 0? -1. That's what I would do. What's a good test point between 0 and 4? 1. That's the easiest number. Okay, and what's a good test point bigger than 4? Okay, maybe 5. If you're feeling like super spirited, you might say 212. Okay, but 5 is going to be the easiest. All right, we're going to put in -1. Okay, now here's a question. Am I plugging -1 into F, or am I plugging into F prime? F prime, this is an F prime number line. So let me just show you guys that this is F prime right here, but actually it's easier to plug in this. This is also F prime. Do you see both of them are F prime? As long as you haven't eliminated anything, okay, they're both the same. Now be careful, if you've eliminated something, then it's not the same, but these are actually the same. It's actually easier to plug in the factored one. Let me show you why, because you're only trying to find negative or positive. If I plug in -1, do you see what I'll get is 3 times -1, which is negative, and then -1 minus 4, which is -5, so that's negative. So it's negative times negative, positive. So I'm going to put a bunch of positive signs just to make sure I understand. Over this whole interval, my f prime is going to be positive. All right, let's test 1. If I test 1, do you see 3 times 1 will be positive? 1 minus 4 will be negative. A positive number times a negative number will be negative. Okay, let's test a number 5. You test 5, do you see you'll get 3 times 5, which is 15, which is positive. 5 minus 4, which is 1, which is positive. Positive times positive is positive. So I'm done with my positive and negatives over my interval, okay? And then I remember my compact formula. So let me rewrite it just to make sure I remember it, okay? My compact formula says this. When f prime is positive, f is increasing. When f prime is negative, f is decreasing. If I ever move from the top row to the bottom row, I have what's called a relative max. If I ever move from the bottom row to the top row, I have what's called a relative min. Okay, so let's look at increasing and decreasing. When f prime is positive, f is increasing. So I have a positive arrow increasing here. It's not a positive arrow, sorry. It's an increasing arrow, then a decreasing arrow, then a positive arrow. And what that means, guys, is kind of cool. This is my f picture. If I were to draw f would look like this. You guys see that? Like I basically draw on the picture, which is so cool. Like you can do this with calculus, okay? And so the other thing that's kind of cool with this is my relative maxes and mins jump out, right? They jump out at me. So what is my relative max going to be? At what point? X equals 0, right? What is my relative min going to be at this for this function? X equals 4. You see how easy that is, okay? The harder thing would be the justification. So think about the justification for relative max and relative min. Guys, if you write down this compact formula, the justification is right there. What's my relative max? The justification for relative max is because f prime changes from positive to negative. And what's your justification for relative min? Because f prime changes from, and that's negative to positive. Is everybody good with the justification? Okay, if they ask you for the points, okay, for the relative max, okay, what you know is this point is 0 comma something, and what you know is this point is 4 comma something, but 0 comma what? What is it, guys? Any idea? How would I get this number right here? Plug 0 into what? F of x or f prime? F of x. So if I plug 0 in there, do you see I get 15? So if they asked you for the relative max, like the point, you would say 0 comma 15. If they said, where is the relative max at, which sometimes they ask, you would say at x equals 0. What's my relative min? What happens if you plug in, is it 4 or negative 4? 4, right? If I plugged in 4, what would I get? What's 16 times 6? 96? So it'd be 64 minus 96 plus 15. Anybody with a calculator? 64 minus 96 plus 15. Anybody know what that is? What is it? Negative 17. So if you were asked, what is the relative min? You'd say 4 comma negative 17. That would be your point. All right. Let me point out something about the justification for relative max, relative min. You cannot say this. Okay. Do you see there's a relative max when you move from the top row to the bottom row? So I said f prime changes from positive to negative. You cannot say f changes from increasing to decreasing. Do you see that that's true? F does change from increasing to decreasing, but this is counted as a definition. That's a definition, and this is considered a justification. So just letting you know, it's not that you're not right. At relative maxes, F actually does change from increasing to decreasing, but it doesn't, but that's not a justification. Okay, so make sure you understand that. You gotta always, justification always has to be F prime or F double prime justification, just because you're in calculus. They want you to justify using calculus. Okay. I also need to know when F is increasing. Okay, guys, when is F increasing? Do you agree from negative infinity to negative 1? Okay. Another way to write it is x is less than negative 1. I don't really care which way you write it. There's another interval where f is increasing. Where is that? 4 to infinity. You could also say where x is greater than 4. Okay, those are all correct answers. And then I'm writing more than you have to. So here, I'll cross that out so you don't feel like you have to write all of that. But either or, okay. I use less interval notation. I use more of this than the interval notation, but either one works. And if you justify, okay, what's your justification for f increasing? Go look at your little compact formula here. So, yeah, Jonathan. Oh, wait, did I pull these numbers out wrong? Sorry. Yeah, not negative 1. That's actually a common mistake. It's negative 1. It's to 0. Is that right? Yeah, sorry about that, guys. Not 4. You guys see what I did? I pulled my, where did I even get the 4? Oh, I pulled my test points rather than my critical points. Okay, actually, very common mistake. And I'm allowed to make it, but you are not. Okay, so, oh, the 4 is right. Oh, okay, the 0 is wrong. Okay, good. All right, so this one is x is less than 0, and this one is x is greater than 4. Thank you. All right. Again, guys, what's your justification for f increasing? F prime positive. So you'd say because f prime is positive, because f prime is positive. Okay. Actually, I wouldn't repeat it. Usually, I would list both of these, and I'd say both of them are because f prime is positive. Okay. What about f decreasing? What would be my reason there? Well, actually, where is f decreasing? What's the interval? 0 to 4. Okay, you could also say 0 is less than x is less than 4. And the reason would be because what? F prime negative. Is everybody good with that? Okay, let me show you something else that students ask. It doesn't matter, guys, if these are parentheses or brackets. Okay, if you want to put brackets there, go for it. I rarely put brackets. Okay, but if you're a PhD in math, you would argue whether it should be parentheses or brackets because it hasn't been settled. Like mathematicians disagree on it. Okay, but on the AP test, they don't care. All right, so parentheses or brackets, we're not going to be super picky about that. There are other areas where it does matter, but not on increasing and decreasing intervals. Okay, you guys feel comfortable? Yeah, okay. So basically you can work on your homework now. If you're online, guys, your homework is in my math lab. Do you guys have any homework questions, either online, guys, or in class that you'd like to still talk about? We have time. So this is a good time to just use me if you need me. You guys are good? Any even past homework or any test questions?
Can we go over number 6 on the homework last night? I mean, yesterday.
Yeah. Can you tell me what it is?
Yes, it is. The one about the runner says, explain why if a runner completes a 6.2 mile race in 38 minutes, then he must have been running exactly 9 miles per hour at least twice in the race.
Tell me the runner completes what?
A 6.2 mile race in 38 minutes.
38 minutes. Is that right? Mm-hmm. Is that right? 6.2 mile race in 38 minutes. Is that right?
Yes, ma'am. And then he must have been running exactly 9 miles an hour at least twice.
Okay. So this is MVT, I think, or IVT. Let's look at this. If he runs 6.2 mile race in 38 minutes, what they want to do is convert this. So convert this to miles per hour. So this would be times his average rate of change. This is like Usain Bolt, right? His average rate of change. Okay, that's going to be 6.2 miles divided by 38 minutes. So that'll be 60 minutes in an hour. Okay, so did you calculate this? Can you tell me what this is? Miles per hour?
Sorry, I calculated it and got a decimal.
11, is that what you said? 11 miles per hour. Okay, So what that means is that if this guy ran this race, on average, this slope here, on average, that would be 11 miles per hour, okay? And so if you look at what he's done, let's just look at time versus this velocity, okay? That means that he started at 0 miles per hour, okay? And at some, on average, he went 11 miles per hour. So what that means by MVT, it means that, you know, no matter how he ran, there's at least one time, there could have been twice, but at least one time, the slope of the secant line, which is 11, is equal to the slope of the tangent line. So at least at an instant in time, at one time at least, he went 11 miles per hour, at least one time, okay? We don't know what time that is, so I'll just call it time 2, okay? The time is from 0 to 38 minutes, okay? So he started at 0 minutes, he ran for 38 minutes, but there, at some time in the middle, he hit 11. Does that make sense? And then we don't know, do we know his final velocity? Oh, his final velocity was he stopped, right? After 38 minutes, he stopped. Does that make sense? So if we look at velocity, because velocity is a continuous function, okay? Because it is continuous, that means he must have hit 9 here, and he must have hit 9 here. Does that make sense? And so he hit 9 at least twice. That's the thinking there. And this is really just a fun question, just to help you understand that this is by IVT, and this right here was developed by MVT. Okay.